All data mining repositories have a similar goal, which is to house data for reporting, analysis, and deriving insights. But their purpose, types of data stored, and how data is accessed differs. In this video, we will learn about some of the characteristics and applications of data warehouses, data marts, and data lakes. A data warehouse is a central repository of data integrated from multiple sources. Data warehouses serve as the single source of truth, storing current and historical data that has been cleansed, conformed, and categorized. When data gets loaded into the data warehouse, it is already modeled and structured for a specific purpose, meaning it's analysis ready. Traditionally, data warehouses are known to store relational data from transactional systems and operational databases, such as CRM, ERP, HR, and finance applications. But with the emergence of NoSQL technologies and new data sources, non-relational data repositories are also being used for data warehousing. Typically, a data warehouse has a three-tier architecture. The bottom tier of the architecture includes the database servers, which could be relational, non-relational, or both, that extract data from different sources. The middle tier of the architecture consists of the OLAP server, a category of software that allows users to process and analyze information coming from multiple database servers. And the topmost tier of the architecture includes the client front-end layer. This tier includes all the tools and applications used for querying, reporting, and analyzing data. In response to the rapid data growth and today's sophisticated analytics tools, data warehouses that once resided in on-premise data centers are moving to the cloud. Compared to their on-premise versions, some of the benefits offered by cloud-based data warehouses include lower costs, limitless storage and compute capabilities, scale on a pay-as-you-go basis, and faster disaster recovery. As an organization, you would opt for a data warehouse when you have massive amounts of data from your operational systems that needs to be readily available for reporting and analysis. Some of the popularly used data warehouses include Teradata Enterprise Data Warehouse Platform, Oracle Exadata, IBM DB2 Warehouse on Cloud, IBM Netezza Performance Server, Amazon Redshift, BigQuery by Google Cloudera's Enterprise Data Hub, and Snowflake Cloud Data Warehouse. A data mart is a subsection of the data warehouse, built specifically for a particular business function, purpose, or community of users. For example, sales or finance groups in an organization accessing data for their quarterly reporting and projections. There are three basic types of data marts: dependent, independent, and hybrid data marts. Dependent data marts are a subsection of an enterprise data warehouse. Since a dependent data mart offers analytical capabilities for a restricted area of the data warehouse, it also provides isolated security and isolated performance. Independent data marts are created from sources other than an enterprise data warehouse, such as internal operational systems or external data. Hybrid data marts combine inputs from data warehouses, operational systems, and external systems. The difference also lies in how data is extracted from the source systems, the transformations that need to be applied, and how the data is transported into the mart. Dependent data marts, for example, pull data from an enterprise data warehouse, where data has already been cleaned and transformed. Independent data marts need to carry out the transformation process on the source data since it is coming directly from operational systems and external sources. Whatever the type, the purpose of a data mart is to provide data to users that is most relevant to them when they need it. Accelerate business processes by providing efficient response times. Provide a cost and time-efficient way in which data-driven decisions can be taken. Improve end-user response time, and provide secure access and control. A data lake is a data repository that can store large amounts of structured, semi-structured, and unstructured data in their native format. While a data warehouse stores data that has been cleaned, processed, and transformed for a specific need, you do not need to define the structure and schema of data before loading into the data lake. You do not even need to know all of the use cases for which you will ultimately be analyzing the data. A data lake exists as a repository of raw data in its native format, straight from the source, to be transformed based on the use case for which it needs to be analyzed. which does not mean that a data lake is a place where data can be dumped without governance. While in the data lake, the data is appropriately classified, protected, and governed. A data lake is a reference architecture that is independent of technology. Data lakes combine a variety of technologies that come together to facilitate agile data exploration for analysts and data scientists. Data lakes can be deployed using cloud object storage, such as Amazon S3, or large-scale distributed systems such as Apache Hadoop, used for processing big data. They can also be deployed on different relational database management systems, as well as NoSQL data repositories that can store very large amounts of data. Data lakes offer a number of benefits, such as the ability to store all types of data, unstructured data such as documents, emails, PDFs, semi-structured data such as JSON, XML, CSV, and logs, as well as structured data from relational databases. The agility to scale based on storage capacity, growing from terabytes to petabytes of data, saving time in defining structures, schemas, and transformations since data is imported in its original format, and the ability to repurpose data in several different ways and wide-ranging use cases. This is extremely beneficial as it is hard for businesses to foresee all the different ways in which you could potentially leverage their data in the future. Some of the vendors that provide technologies, platforms, and reference architectures for data lakes include Amazon, Cloudera, Google, IBM, Informatica, Microsoft, Oracle, SAS, Snowflake, Teradata, and Zeloni. In this video, we learned about some of the capabilities of data mining repositories, such as data warehouses, data marts, and data lakes. While they all have a similar goal, they need to be evaluated within the context of the use case and technology infrastructure for selecting the one that works best for an organization's needs.